Hey, good morning, everybody. So today we are going to finish up the notes from Tuesday. So today's Wednesday. January? What is today? 13th, I think. So, sufficient condition number 3. I'll make this quick for you. So sufficient condition number 3, what we're talking about again is the parallelograms, right? So we want to prove that the diagonals bisect each other in a parallelogram. So we want to prove that these are congruent to each other and that these are congruent to each other, right? That they're cut in half. So again, anytime you're dealing with a parallelogram and you want to prove its properties, probably the easiest way is to look at the triangles, because as you notice, like this triangle here, okay, that's two sides. So if we can prove that this triangle is congruent to this one, then we can prove that this is in fact true, that their sides are congruent by using corresponding parts of congruent triangles. So we just need to look at it and say, okay, how can we prove that these triangles are congruent? All right, so again, state your given, right? Which in this case, ABCD is a parallelogram. Okay, so that's our given. It's up above. So we're always going to state that. And what we want to prove, again, is that the diagonals bisect each other, or that they're congruent. And this happens to be 6 steps. Not that you would know that per se, but just writing it down. So line DO is congruent to BO. And line CO is congruent to line AO. That's what we're trying to prove. And we already know that we're going to prove the triangles are congruent, so this is going to end up being CPCTC. All right, so coming back up here, because it is a parallelogram, that tells us, don't forget, that these are congruent, parallel lines, right? Okay, because it is a parallelogram. So how can we go about proving, once again, that this triangle is congruent? Well, we can either do side, 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 but in this case, what we're trying to prove is the side of the triangles, so we're not going to be able to use side, side, side. You can't use the sides that you're trying to prove in the actual proof itself. Okay, we also have side, angle, side. Okay, both side, angle, side, we would have to use either this one and this one, or this one and this one. And again, it uses a side of the triangle or to be able to prove it, so that's not going to work either. We also have angle, side, angle, 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 side, and hypotenuse, leg. Now, hypotenuse, leg doesn't work because these are not right 90-degree angles, so we can't use that one. So it's got to be one of the two. All right. So the problem with that is we need to either prove that these two are congruent, right, which we can pretty easily, and then these two. So there are a couple ways actually to prove this. So we can prove that these two are, and maybe these two are, right, and then maybe these are, right. That would give us angle, angle, side. So why don't we go ahead and do that? We could do these ones too in the corner. We could do this one in the corner. We could do this one in the corner. Those two angles, and it's going to use the same theorem. But I say we mix it up here a little bit. So how do we know that angle CBO is congruent to angle ADO? And yes, notice I'm switching the direction. You have to, because these opposite angles are congruent, right? Well, we know it's equal because these are vertical angles. So COB and AOD. So BOC. Actually, before we even do that, let's put that down here for this one. So, or COB angle is congruent to AOD angle. Okay, and we know that, as we just talked about, because of the vertical angle theorem. All right, and then let's see. Oh, well, we got to have this side, right? Well, how do we know that these sides are congruent in this triangle? Because they're the opposite sides on a parallelogram, right? It says it's a parallelogram. Okay, well, if it's a parallelogram, one of the conditions or one of the properties is that opposite sides are congruent. So, number 2, we could say that line AD, is congruent to line CB. Okay, and we know that because of the definition of a parallelogram. Okay, and then 4 and 5, let's see here. So we know that 5 is going to be the triangle, and we got 2 already done. And we know we're going to use angle, angle, side. So it's going to be triangle BOC is congruent to DAO, or backwards, either, or DOA. Either way works. AOD, COB, you could have done the same things before. Okay, so what are we missing? So we have the side and we have an angle. Side and an angle, right? Side and an angle. So we need to figure out this side. Well, we know that these are parallel lines, and this is a transversal that cuts right between it. So that means that these two angles, let's see, BCO, is congruent to angle, let's see, B had no marks, C had 2 marks, O had 1, so we got to start with D, so DAO. And they are congruent because of the alternate interior angle theorem. Okay, there's 2 parallel lines because it's a parallelogram, there's a transversal. They're on the opposite insides of those parallel lines, right? So that's alternate interior angle theorem. So there you go. So that proves that given we have a parallelogram, that because we can prove this triangle is congruent to this one, then that means the sides of the triangles are all congruent, right? Because of corresponding parts of congruent triangles. So that tells you when you do have a parallelogram, you do also have the diagonals that bisect each other, and that's because they're part of the interior triangles of a parallelogram. Okay? All right. So hopefully that gives you some time to copy that down. Of course, if you need to, you can always pause it. Okay? Also, you could have done either one of these. We used angle, angle, side. You could have also done angle, side, angle. If you did this angle, this side, and this angle, you would have just used alternate interior angles twice. You would have used this theorem twice, once here and once here, if you wanted to use ASA. Okay, so there was actually 2 ways that you could prove this. All right, sufficient condition number 4 is that one pair of sides is both parallel and congruent. Okay, so again, you cannot use it if it's already like in the component, right? So what's our given here? I guess it's ABDC. ABCD is a parallelogram. This is given. Okay, and we want to prove that BC, so one outside edge, is congruent to AD, and BC is parallel to AD. Okay, so we just want to prove that that it is in fact both parallel and congruent. Well, because it's a parallelogram, that actually simplifies one part of this. You're not really supposed to put it within the proof itself, but it's not saying, to be more specific, this is not saying, oh, you have to prove that it's congruent and you have to prove that it's parallel. We already know that it's parallel, so really what we're saying is that one side is being proven to be both parallel and congruent, right? So really all we're trying to do is prove its congruency. That's what we're trying to do. Okay, so we already know, since it's a parallelogram, we can prove it if we can prove the triangles are congruent. So we're going to use the corresponding parts of congruent triangles are congruent. All right, now, before we do anything else, we're going to label the fact that we know already BC is parallel to AD because of the fact that it is a parallelogram. That is the definition of a parallelogram, right? It's not just a condition. It's a definition of a parallelogram. Otherwise, there's no reason why it would be called a parallelogram. But remember, as we talked about it, parallelograms are four-sided shapes that have opposite sides that are parallel. Okay, it doesn't say in the definition that they are congruent, but it does say that the opposite sides are parallel. All right, so number 3, we're going to go ahead and we're going to use our triangle proof. So we know that BD is congruent no matter which triangle you're looking at. So we're going to say BD is congruent to BD, and that is reflexive property. Okay. We also know that, let's see, that it's two parallel lines, right? Because it's a parallelogram. So we know these two angles are congruent, and we know these two are congruent. So let's see, angle CBD and ADB. CDB and ADB. That doesn't sound right. CBD. Yeah, they shouldn't go the same order. Okay, we know that because, you guessed it, AIA theorem. There are alternate interior angles. And same for the others, right? So if we're looking at the two lines now. Okay, so you have angle, let's see, CDB this time. So we're going to switch it up. CDB is congruent to angle ABD. All right, and this is the same theorem, alternate interior angle theorem. Okay, so lastly, prove that their triangles are, we just did. We have, let's see, we have an angle, a side in between, and then our other angle. So this is ASA. So triangle ADB is congruent to triangle CBD. And this is by angle, side, angle. Again, order matters. Order matters. So notice ADB. So no marks, 1 mark, 2 marks. Okay, and then CBD. No marks, 1 mark, 2 marks. So go in the same order. It has to correlate with the correct sides and correct components, okay? So what did we prove here? We proved that a parallelogram not only has parallel sides, but also that one pair of sides is both parallel and congruent. Okay, that's it for the notes. Hopefully it didn't take up too much of your time. Go ahead and fill this out and make sure to get everything down. If you need to pause it, go ahead. And then finish your practice assignment from yesterday where you were supposed to do the first 2. And I will post a key for that later on today. All right, guys, I missed